All right, so we're going to talk about solving quadratic equations. Now, we did this a little bit in one of the previous lessons, but when you just have an x squared, so a quadratic equation, the biggest power you have is a 2, right? And when you are solving, we usually have like an x squared and then a term that has an x and then like a number, right? And then we do our factoring and whatever. But when we have just an x squared and there's no other x on here, then we can just solve for that x right there. So if I want to solve for x, then it's kind of like those Russian nesting dolls, right? You got to undo the stuff on the outside before you make it to the actual x, right? So I'm going to add the 31. This is just solving for a variable. So I have 4x squared is equal to 80. And then I would need to get rid of this 4 right here. So I'm going to divide by 4. So I've got x squared is equal to 20. And then to get rid of the square, I would need to square root. And when you square root in an equation, you get a positive answer and a negative answer. Now, whenever you square root something, you need to think about, can you reduce that root, you know, or anything like that. So here's the thing. You need to do your factor tree, see if you can reduce this root. So you have 2 times 10, and then 10 is 2 times 5. So I have 2 of the 2's, and then I have a 5. So this will be my perfect square, and then this is the prime number that's going to stay in there, right? So if I square root each of those, I end up with 2 square roots of 5. And those are my 2 answers. I have 2 answers on all of these. And I know that because my biggest power is 2. All right? So I have 2 answers on all of these because they're quadratic, and quadratics have an exponent of 2. So on number 2, the first thing we should do is subtract this 9. So that gives me 3x squared is equal to negative 9. And then I'm going to divide by 3. So now I have x squared is equal to negative 3. And then to get rid of that square, I will square root, and I know that that gives me a positive answer and a negative answer. So herein lies the problem. If I square root a number, that means I'm looking for a number that will multiply by itself to get this number. So what is the problem with multiplying by itself and coming up with a negative 3? Okay, nothing multiplies by itself to get what? A negative 3. Why not? Okay, nothing multiplied by itself ever comes out to be negative. It's always positive, correct? And you're going to find out in the next lesson we do have an answer for this, but for now we have no real solutions. You cannot say no solution because there is a solution, it's just not real. It's imaginary. Okay, now we did this in Algebra 1, rationalizing the denominator, but I'm going to give you a little miniature review. Okay, so we do not leave square roots in denominators. That is a no-no. So what could I multiply by the square root of 3 that's going to get rid of that root? You're so close with 3. It's not 3. It's square root of 3. Thank you. But remember, you have to do that on top and bottom. So I can multiply things that are not under a square root And I can multiply things that are under square roots, but I can't do like something not under a root with something that is under a root. So this would just be 4 times the square root of 3. Like I couldn't get 12. And then we already established that the square root of 3 times the square root of 3 is 3. Correct? Now you could reduce here if this was a number that both of these divided by the same thing, right? I can't reduce this 3 and this 3 because this one's under a root and this one is not, right? But I could do the 4 and the 3 if they actually reduced. So on part B, we would need to multiply by what? The square root of 7 over square root of 7. So on top, that would give me 2 square roots of 7 all over what? 7. Okay, so there's our little miniature review on rationalizing a denominator, which we're going to need. So I've got to solve for x. Notice, again, I only have this x here. I don't have like an x squared and an x. So how am I going to solve for x on this one? Good. Instead of dividing by 2/5, right? We don't like to divide by fractions. We'll multiply by the reciprocal. So I'm going to multiply by 5 over 2. So now I have the x plus 3 quantity squared is equal to 25 over 2, and that does not reduce, right? Okay, and then what do I need to do? I'm going to need to get rid of this square, right? Because in order to get inside the parentheses, I have to take care of the part that's on the outside first. So I will square root, and I'm not going to forget that I have a positive answer and a negative answer, right? So I have x plus 3 is equal to plus or minus. Now, when you square root a fraction, you have to square root the top and the bottom, right? So the square root of 25 is 5. And then 2 is a prime number, correct? So I can't reduce that. So it's just the square root of 2 on the bottom. But this isn't simplified, right? I don't leave a root on the bottom. So how do I take care of that? All right, so I'm going to multiply by the square root of 2 over the square root of 2. And this is just kind of chilling over here until I get done fixing the right side. So I have plus or minus. This will give me 5 times the square root of 2 on top. And on bottom, I would end up with 2. Now that that's fully simplified, I can go ahead and subtract the 3. Now, when you move this over, we usually put things at the back, but I want you to put it in front of that plus and minus sign. So that would give you negative 3 plus or minus 5 square roots of 2 over 2. And that represents 2 answers, okay? I have negative 3 plus 5 square roots of 2 over 2. And then I also have negative 3 minus 5 square roots of 2 over 2. Okay, you may leave it like this, just so long as you know that that represents 2 separate answers, right? All right, so number 4, the first thing we should do is multiply by the reciprocal, which is 4/3. So I have x plus 1 squared is equal to 40 over 3, which will not reduce. Then to be able to access inside here, I'm going to have to get rid of this squared. So I will square root and not forget my positive and negative answer I'm going to get with that. So I have x plus 1 is equal to. Now, 40 is not a perfect square, correct? So we need to see about splitting 40 up. So 40 is 2 times 20. 20 is 2 times 10. And 10 is 2 times 5. Now, how many of these 2's? I have 3 of them. How many is going to make my perfect square? 2 of them, right? And what is that going to leave left over? A 2 and a 5. So I'm going to multiply those together to make 10. So if I square root this, I get 2 square roots of 10. All right, and then the bottom is just a prime number, correct? So that would just be the square root of 3. Now, are we done with this side? No, we've got to take care of the square root of 3. So I will, because I have to square root top and bottom. So I multiply by square root of 3 over the square root of 3. So still chilling over here on the left. All right, so remember you multiply things that are on the outside of your roots and things on the inside. So this would be 2 times 1, which is just 2, and then 10 times 3 is 30, all over 3. And I can't reduce this. 30 doesn't reduce because if you split 30 up, you get 2 and 15, right? And 15 is 3 and 5. Do you have 2 of anything? Okay, so 30 can't be reduced. Now you'll subtract that 1, and I want you to put that where? In the front of the plus and minus. So you have negative 1 plus or minus 2 square roots of 30 over 3. And please make sure that you're putting your root completely over whatever's supposed to be underneath it as well. So on number 5, I've added a little bit extra on the outside. So remember, before you get to this little grouping right here, you need to get rid of whatever's on the outside of it. So I'm going to add 5 first. So I have 2 times the quantity x plus 2 squared equals 13. Now I can go ahead and divide by the 2. 13 and 2 are both prime numbers, so that's not going to reduce. So that leaves me with the quantity x plus 2 squared equal to 13 over 2. So now, so I can get inside of here, I have to square root to get rid of that square. But I'm not going to forget that I have a positive answer and a negative answer. So x plus 2 is equal to. Now, we already know that 13 is a prime number, so I'm not going to be able to reduce that. And then I also know that 2 is a prime number, so I can't reduce that. So I just end up with the square root of 13 over the square root of 2. But I can't leave it like this, right? Because I have this root in the bottom. That's a problem. So I will multiply by that root on top and the bottom. And the left side, still chilling like a villain. All right, so I can multiply what's on the inside of these roots on top. 13 times 2 gives me 26. And that's not going to split because those are 2 prime numbers, right? All over 2. And then the last thing I do is subtract 2, and I'm going to put that right in front of the plus or minus. So I get x equals negative 2 plus or minus the square root of 26 over 2. And remember, that represents 2 answers. We have 2 answers on all of these. Now, when you end up having an x squared and an x, regardless of whether I have a number or not, you should immediately, in your head, think, I need a factor. Okay? So anytime you see an x squared and an x, then you need to think, if I'm going to solve, I've got to factor. Now, it just so happens that we also have a number, but we don't want the number over here. We want the number over here, right? We want everything to be on the left-hand side, or on one side. It really doesn't matter what side. However, I don't want that to be negative, right? We'd like for our x squared to be positive. So I've got x squared minus 4x minus 45. And remember, you want this to be in order, so like don't stick your 45 in the middle because then it's not in order, right? And then when you see that trinomial, you're immediately going to factor it. So we kind of went over this in another lesson, right? The factoring for sure, but then the setting it equal to 0, we did a little bit of that. So I have a minus in the back, which means a plus and a minus, and then we've got our x's, right? And then I need two numbers that are going to multiply to make that 45 and subtract to make 4. 5 and 9. And since I want this middle number to be negative, the 9 is going to go with the negative and the 5 will go with the positive because negative 9 and positive 5 make negative 4. So now that you factored, you take each of those factors and you set them equal to 0. So I'm going to take the x plus 5 and set that equal to 0, and the x minus 9 and set that equal to 0. So that's going to give me negative 5 and positive 9. And like I said, we did a few of these in a previous lesson when we were factoring, so it's not really new info. All right, so same thing here. I want all of this on one side, right? So I'm going to go ahead and subtract the 48. And the minute that I see an x squared and an x, I know that I'm going to end up factoring, okay? So I've got x squared plus 2x minus 48 equals 0. And then I'm going to go ahead and start factoring because I've got 1 in front of my x squared, right? Which is key. So again, minus at the back, so that means I have plus and a minus, x and x. And what's going to multiply to make 48 and subtract to make 2? 8 and 6. And I want this middle number to be positive. So I'm going to put the 8 with the positive and the 6 over here because 8 and negative 6 make positive 2. Then I set those both equal to 0. So x plus 8 equals 0. X minus 6 equals 0. So I end up with negative 8 and positive 6. And again, I should have two answers on everything, right? Okay, so I didn't put any directions up here, but let's just say I said to find the zeros. Okay? Finding x-intercepts, solving, and finding zeros all mean the same thing. So I'm going to say that one more time. Finding x-intercepts, solving, and finding zeros, those are all the same thing. It doesn't matter how I say it. So on your worksheets, I will constantly change how I say it just so that you're used to seeing it 50 bazillion different ways. Okay? So I'm looking at this, and the first thing I'm going to do when I'm finding zeros is set it equal to 0. So I've got 2x squared minus 11x plus 12. The second thing I'm going to do is I'm going to look to see if I can divide all of these terms by the same number. If so, then I would divide this side and this side, right? It's an equation. So if all of these divided by 2, I would divide this side by 2 and this side by 2, okay? In this case, I can't do that, right? So I notice that I have a number in the front, which that's a problem. So we're going to do the illegal move so that we can factor. So I'm going to take the 2 and multiply it times the 12 at the back, which is going to give me 24. And then I do my whole factoring thing. This time, though, we have a plus at the back, which means 2 of what's up front. So I have 2 minus signs and the x's. And then the two numbers that will multiply to make 24 and add to make 11. That would be 8 and 3, right? And it doesn't matter where I put them because these are both minus signs, right? But I can't forget, once I get it factored, to undo that illegal move. So I'm going to divide both of these by 2. And remember, you always reduce if you can reduce. So 8 divided by 2 is 4. But 3 over 2 does not reduce at all, so I'm going to go ahead and move the 2 up front. Remember, if it does reduce, you need to reduce before you move anything. Now unfactored, I'm going to set those equal to 0. So x minus 4 equals 0, and 2x minus 3 equals 0. That's going to give me a positive 4. And then over here to solve for x, I would have to add 3. And then divide by 2. So I get 3 halves. Now I'm going to show you something, and some people like to do it this way and others don't. It just kind of depends. If you're just factoring, you have to move that up to the front, right? Because this would be the factored form of your equation, right? But if you're solving, before you move that 2, if you've already reduced this, you could set that equal to 0. Like, what if I set the x minus 3 halves equal to 0? I would add the 3 halves, right? And isn't that your answer? Yeah. So technically, you could skip this step and this step and this one, right? And just do this. But if you're not comfortable doing that, then by all means, move the bottom to the front and just go through the motions, okay? I mean, a couple extra steps isn't going to, you know, kill you. But just notice that that's something that you can do, and it cuts down on work, okay? All right, so on this one, first thing I'm going to do is set it equal to 0, because I'm finding the zeros, x-intercepts, the solutions. And I'm going to look to see if I can divide all of these by anything. I can't. So to factor, I'm going to have to do the illegal move because I've got that number in front of my x squared. So I'm going to take that 4 times the back, which is going to give me a 12. And I'm going to do my factoring. So look back there, I've got a plus sign, so that means 2 of what's up here. So I have 2 minus signs and my x's. And then what's going to multiply to make the 12 and add to make 13? 12 and 1. And since the signs are the same, it doesn't matter where I put those two numbers. But now I have to remember to divide by the 4. So 12 divided by 4 is going to give me 3. 1 divides by 4, it doesn't reduce, right? So I'm going to move the 4 to the front. Now, since I'm solving, I could realize that this is just going to end up giving me a positive 1/4, yes? But I'm going to go ahead and go through the motions here, just so we can kind of keep everything the same. So I'm going to set both of those factors equal to 0, which gives me a positive 3. And then on this side I have to add the 1 and then divide by 4, which if I would have set this equal to 0, correct, I would already have the 1/4, right? I'm just going to write them together just because. Now, I do want to give you one more of these. So this would be like number 10. What if I gave you x squared minus 4x equals 0? The problem is that we normally have a number, right? Or something to move over here. So we only have 2 terms, so I can't, and they're not perfect squares, right? I mean, this is, and 4 is, but x to the first is not. So, but every time I see an x squared and an x, I should be thinking in my mind that I have to factor. But remember, there's more than just one way to factor. You have a common factor here, right? Yeah. So you can take out an x, which leaves you with x minus 4. And now you have two factors that are being multiplied. Set them both equal to 0. So I don't have to do anything on this one, but this one I just need to add 4. So x is 4. And then I have my two answers, right? So if you're missing that third term and both of these have an x, factor out an x. Other thing I want to mention is, let's say that my two answers were x equals 4 and x equals 4. Okay, remember when you get two of the same, that just means that you had a perfect square trinomial, right? But I don't write them both down. Like, that's just not how we do it. So what you would need to do is you would need to write down the 4, and then in parentheses you're going to tell me how many of them you have by saying that that is a multiplicity, but I'm going to let you abbreviate to mult of 2, because I have two of those. All right? So if you get two of the same, you're going to write down the answer you got and then put multiplicity of 2, because you're not going to have more than two answers in this lesson. Okay? So if I had like 3 of the same answer, like eventually we will, you would put multiplicity of 3. You just tell me how many of those answers that you have.